Hi, Lee.
Hi.
Hi, can you hear me?
Your voice is quite low.
Quite low?
Yes.
Now it's okay? Low? Still quite, still quite low?
Okay.
Better? Uh, maybe I stop my video. Is that better? Low?
I can hear you.
Okay. Maybe I more close to the microphone. Good morning, everyone. Uh, so now we already I mean the grouping is already finalized. So I will discuss with you about the first. Do you have any problem with the connection with your iPhone or Android phone with your local computer and use MATLAB to read the data? So is anyone have a problem? Which group you have successfully connected to the uh, a smartphone with MATLAB? Hi. How about your group? Yeah. Have you connect to the smartphone and install the MATLAB? Oh, that's great. Great. So yeah. How about the other group? Maybe I know, publish the group information. Uh, Maybe I find the group information and we can. So Emilia, how about your group? Emilia, Amy, and Jasmine, you are in the same group, and Emilia is a leader. Okay. Okay. So yeah, so maybe other group member if you can install Leview, that's also okay. But yeah, but we need the connection maybe today or if you let me or Lee to help you. Yeah. So how about Jason group? Jason,
Yeah, we good.
you can connect to the smartphone.
Yeah, Dan has the app. We good.
Okay, that's great. So do you need me to do some demonstration how to connect? If need, and just let me know. You are
Yeah, it could be helpful, I guess.
okay. So Daniel, Jason, and Jessica, you are the group two, with Jason as a leader, and the group four, Juliet, Malika, and Pranisa, and Zorin, and Pranisa is a group leader. Is that right? My recall right? Okay. So in that case, we have a group and also group one with Amelia as a leader, and is mainly focused on fall detection. So the group two, the second group with Jason Luther, uh, Luther is the team leader. Is mainly for motion. Access monitoring. So it's the third group is group leader is Pranisa, is mainly for fault detection as well. So this is the our three group. Uh, Today our plan is first we discuss again for the connection between the MATLAB and the your software with the app. And then we will discuss. I already sent a video to explain what is accelerometer, how accelerometer work. So what's the physical theory behind? And I also suggest you to read how what's a gyroscope to measure angular velocity, and also we have a magnetometer, how to use magnetometer to detect uh, the local magnetic field. Yeah, this is if you can detect the magnetic field, you will know uh, the direction. For example, sometimes we call the yaw angle, so we can detect. And after that, we can teach you how to use the IMU to identify the inclination angle, and then later we will discuss about how to identify a three sensitive exercise for the accelerometer, and then we will use this technique to discuss about calibration of the accelerometer if we have time. And then we will supervise you individually for each group. We will maybe group discussion and to supervise you to install and to get the connection. So first, I think I will just demo quickly, and then I think this one may be more efficient if I go to group and I this group with group. That will be more efficient. And first, I do a very quick demonstration. Again for the connection. Uh, so we first, I mean, I share the screen. So I share the screen and I open the. Also, MATLAB is already open. Yeah. So this is the MATLAB. We first go to I think so I no need to open two MATLAB. So I go to the this is MATLAB environment. So first you need to find where you put your uh, main code here. For example, if I simulate this one, I need to change the path to there. But then I didn't because here we cannot connect because I didn't open the my iPhone correctly. But now we look at where I put my main program. So it's here. So I put in in their folder in my desktop. So I put three. You need to put three because first you have the zipped file, and then you unzip this one, and then you can get this one. This one you can have a normally you have a several things here. So it's in the for iOS. It's in this module, and then you after you unzip, you will have three. If you unzip one of this one, you will have three. If I show you the, you have three ML there. So you need to install put them in the open folder, and then you just run main. You just can run main, But before you run that, you need to connect with your um, mm, smartphone. So first install, if you are iPhone, you will install called sensor log. So sensor log, I'm not sure, can you see my screen? Maybe I, so I'm not sure you can see the screen. So this is my iPhone, and then I install this called the sensor log, and then I click on, and this is the sensor log. I'm not sure you can see it or not, but this is the one, and then I select the setting. There's all the settings. There's a doc, I mean Word document to tell you how to change the settings. And I according to that document, I change the setting, and this is the setting I set, and then I simply uh, uh, touch down button, then back to the working window, and then I just push record, and then start to record, and then this should be connected. But if I check they have the IP address, we should match the IP address, and then we have here. Mm, so this IP address is 192.160, and so they are matched. So and not only the IP address and also the port number. The port number is 64949. When you connect to the your iPhone with the MATLAB, the iPhone actually have the information. You just need to match. You change the IP address and the port number. You need to match with the smartphone app. They have the one. I'm not sure, it's maybe difficult to see it, but yeah, this is a connection, and then we can just simply run this one and change the port. So I'm okay. So this time it works. So it's quite simple. If I very fast, it will moving fastly. So so this is the whole connected to the iPhone. So the next I want to introduce why if we change the my direction of the iPhone or swing, and then the reading will change. So what's the theory behind? And so accelerometer, you can think about how to design accelerometer. The long time ago, I mean they use a pendulum can measure acceleration. You assume you put a pendulum in a train, for example, your fast train, and then the train is accelerate in one direction, and then the pendulum will have angle, right? Will before if no acceleration, it will be consistent with the gravity. But when it has acceleration, it will have an angle. Actually, the bigger the angle is bigger. So this we can use this kind of pendulum can directly measure the acceleration, but that one is not very accurate. Why? Because this is a nonlinear relationship. If because the angle and the acceleration is nonlinear relationship, and then some engineer think another way called force feedback. So they not let the pendulum move. They just put a sensor. They can sense how big it is the force we need to let it keep to the original direction. So this is another kind of very popular called force feedback accelerometer. But recently, because all before they use very big mechanical system, it will be very big. So the accelerometer normally quite big. They put in the missile, they put in the airplane, and put in the for military use mainly, and then they can build a very high accurate accelerometer. But in recent years, because the mass technology is like they can build a nano uh, scale small mechanical accelerometer, so they can build a wearable device, like for example the iPhone and the iPhone watch. You can put the accelerometer, gyroscope, and the magnetometer, all of them together form a initial measurement unit. So the initial measurement unit together, we can measure, actually theoretically, you can measure 6 degrees of freedom anytime. For example, you go to university, and this one can tell you your 3D position, and also should tell you the three altitude position change, altitude orientation. For example, your yaw angle, your pitch angle, and your roll angle, and this information they can theoretically they can estimate, they can tell you, but because of the drift of the sensors, and especially because the MEM sensor is quite small, they cannot build a very accurate MEM sensor. So they cannot be very accurate. They only can maybe 1 or 2 minutes or 10 minutes they can do good estimation. Especially for the position one, it's hard. So, uh, but they can combine with other sensors. For example, GPS can combine with IMU, because GPS have no accumulation error. They can uh, determine the location very accurate. They not degrade with time. But for IMU, after alignment, just alignment if we use GPS information, we can alignment with GPS first, and then in between, because GPS normally update is quite slow, maybe sometimes 1 hertz is one, that means 1 minute one updation, and then between we can use IMU to estimate all the information, even the speed, the angular velocity, all of the things can estimate. So IMU is so powerful, and why? So what's the theory behind? I put a video in my email. I think we can watch this video. I hope you also watch this video as well at home. Yeah. So slow.
The most common reaction to a birch arrangement is, I didn't know flowers could look like this. I'm Brittany Ash. I'm a floral artist and the founder and director of Birch. I use Squarespace as a tool to express what my business is to those who don't get to experience
value of x, which helps us to infer the value of acceleration.
So we look at this video. So this video is quite intuitive. It's quite good. So we look at first they introduce what's accelerometer.
Hello viewers, Practical Ninjas brings you another interesting video. In this video, we are going to understand how accelerometer works. We all have heard about accelerometer, gyroscope and magnetometers built into our smartphones. Using these sensors, smartphone processors understand the orientation of the phone in 3D space and takes actions accordingly. Let's take some of our time to understand how these actually work.
So the accelerometer, so for the iPhone, you can see you have lots of sensors, not only just IMU sensor, you have other temperature and some other sensors. So at least each smartphone, they have one accelerometer, one magnetometers, and a gyroscope. Today we'll mainly introduce accelerometer. If you are interested, you can go to the same location. You can find other video for magnetometer and gyroscope. So for accelerometer, so you can see
Take some of our time to understand how these actually work. First, let's start by understanding the basic physics of acceleration measurement using a spring and mass system. As seen in the diagram, a body of mass m is attached to a wall by a spring having spring coefficient k. When force F is applied to a mass m, it is displaced in the direction of the force by amount x with acceleration a. Using Newton's law and writing the force conserving equation, we get F equals ma, which equals Fs. This Fs is nothing but the force due to the spring tension. The force due to spring tension is written as kx, where x.
Basically, this is according Newton's law, F equal ma. This I think in the high school physics you already learned that. So I think F equal to ma, and then this have a spring, and spring is related with force is kx. So the x is the changing of the spring, and if the changing the distance is bigger, that means the higher acceleration. So this is the physical meaning. Physical theory behind. But if you want to build a smaller one, you need to normally have sensing the distance. So sensing the distance, there's three kinds of sensor. One called resistance. If for example you have a potential meter, right? You remember, like, if you move a little bit of the potential meter, the one of the port, and then you will change the resistance. So this one can be a kind of idea how to measure the distance change based on the resistance change. This is called resistance sensing. And you also can use capacitance sensing. So if you, for example, you have a capacitor, but if the two polar, the distance is if change, and then the capacitance also change. So based on the capacitance change, you can measure the distance change. So this is another kind of sensing method for distance. And also we have other called inductance. So I will not introduce too much, but the problem is, like, why we use this kind of things, because we cannot use very big this cannot build a very big accelerometer. We want wearable, so normally the dimension is very small. So we need to use this kind of sensing technology in the nanometer scale. So we continue.
Is the displacement of the body from initial rest position. Equating the forces, we get m. We can calculate the acceleration on the body.
So these are three different called resistive technique, capacitive technique, and inductive technique I just mentioned. So if you are interested, you can watch individual video for capacitive techniques. You can search in the YouTube. There's lots of YouTube you can find. And then they talking about capacitance technique. So they mainly can measure distance. So later they talking about called MEMS technology. This is called macro electromechanical system. So this is a very small. So they can build the the capacitors there, and then you can see if there's acceleration. If there's acceleration, this will change the screen. This is a spring. The spring will change, and then they will move. So the two polar of the capacitor the distance will change. And if you can measure the distance change, and then you can measure the acceleration. So this is the theory.
In the diagram, we can see a series of fixed plates on the outer assembly. Then there is an internal movable assembly. It has a small mass and is connected to outer assembly using spring contacts. The movable assembly also has plates which form a capacitor with plates of the outer fixed assembly. As the system moves due to acceleration, the internal assembly moves, and due to displacement, the value of different capacitors change. By measuring these changes in capacitance, we can infer the acceleration acting on the body. Having such multiple MEM system in different planes, that is x, y and z, the
So you have that's why I called this one is a tri-axis uh, accelerometer. So this is have three axes. They have three accelerometer. So they can build a orthogonal 3D uh, uh, coordinator to measure the acceleration. So that means for any direction you can fully measure. So no matter the direction is in uh, uh, which side, and you can measure. So this one is called completed measurement of acceleration. So sometimes they only have one axis accelerometer and all two axis accelerometer. So they are not completed. But we have all our accelerometer and gyroscope. We are all three exercise. So it's very completed. So it's good. And you also continue. You can look at
Have
some
you ever
other.
wondered how your phone manages to know what direction you're holding it? It's using a device called an accelerometer. It works by sensing the acceleration of gravity, and then you can calculate what direction the phone is facing. But how does a piece of electronics sense something mechanical like acceleration? The answer is MEMS, microelectromechanical signature. MEMS manufacturers use similar technical structures that you might find in this darker area. Now,
So I want there's lots of video you can search. So I don't want to go too far. But actually they have introduced about a gyroscope as well. The gyroscope is also a kind of interesting topic, and how to measure the angular velocity. Can you think of the theory behind? Actually, like there's one of the acceleration is related with the angular velocity. When you rotate when object is rotating, and then they will generate a kind of acceleration, and then this acceleration again you can use uh, force to measure. So this is similar as the accelerometer, but they use different input, measure different kind of input. So this is lots of interesting things. I don't want to go too deep, maybe make you confused. So I stop here. You just know what's the theory behind. So it's not that mystery. So if you can understand the theory behind, and in the future you can maybe more intuitive to understand accelerometer. That's one topic. Another topic I think we put how to measure. Uh, I think for how to measure the inclination. So how to measure the inclination? Use accelerometer. Inclination. Uh, this part I think maybe I ask Li Wang. Hi Li.
Yes.
Maybe my voice is here is not very clear. Maybe we exchange our role. Maybe you are the host, and then you give explanation. Maybe you open your video. We open your camera. Yeah. Okay. Yeah. Thank you. And I give you the host. Yeah. Maybe I quit sharing.
I introduce a little bit mathematicals here. So, so when when you are not moving, you are stay there. There's still some readings from the accelerometers. That's actually actually the gravity. So as you can see here, I'll take a single accelerator as an example. So if we want to calculate the theta here, if we want to calculate this theta, that's a very simple mathematical cellular functions. So if we draw the gravity is actually the projection on the axis. So we draw this like so this part, the right one, is actually the output of x. It's the x reading from the accelerator. So how to calculate this one? Is so we know this side and this side. We can calculate this theta. We can prove this one. This two angle is equal. So ACX is equal to J times sin theta. If we want to know the theta, we know the gravity and we have the reading of the accelerator, so we can know theta is equal to so we can get the theta of this side, and this is very simple mathematics. You will be used in these projects. I think you have learned this in your high school.
Sorry, Lee. So this one may be mainly used for height movement detection, but there's no group select this topic. Maybe this one is just give them knowledge if in the future they want to detect the height movement. Yeah.
Yeah, but they still need to know what
Yes,
the
yes.
readings are.
Yes, yes. Yeah, yeah. Continue.
This is your reading.
Yeah, the next topic may be very important. You need show how to identify different exercise, different sensitivity exercise axis.
Okay.
Mm.
Uh,
So the second one.
so we also have a link here. How to identify the axis of the accelerator. There's two ways to do so. The first one is we can find the direction from dataset. So in the future, if you are doing hardware works, you will purchase some chips. They will give you a menu. The manufacturer will give you a menu of it. It's called data sheet. So I'll take an example as this one. As you can see, this chip is called ADXL344. The manufacturer will give you a data set like this, and it draws the axis coordinate system here. So accordingly, we know the x-axis, y-axis, and z. So this dot point, it means the direction is from the chip towards me. If there is an X mark, that means the direction is from me to the chip. Actually, I have is this clear to see? So here, you can see this is a y-axis, and this is x-axis. But obviously, you have connected your smartphone to the MATLAB. So let's start my. So I'm start my. So as you can see on the screen, the red lines here is around -1. So I keep my phone top upright. So this means the top. So this means the red line is the x of the top to the bottom of my phone.
Maybe the reason is because you want to the accelerometer sensitive to the local gravity. So your local gravity is the only input for the accelerometer, for the 3 accelerometers. So the only because there's no other acceleration, you put it steady still, right? And then the only input is directly go down. I mean straightly. So in that case, if the this measurement -1, this corresponding to which reading? To x or y or z? So x, so -1, you have a -1 there. You can see that's the right line. A little is the right line. So the right line is.
We are identify the direction, not the axis.
How about we do like this? You just go keep this location until this finished, and then we look at x, y, z. We look at yeah, when this finish, and then you look at yeah, so which is bigger?
So this one is
yeah.
the
So
second axis.
Yeah, second axis is y axis. In that case, in the y, your input is downside, right? Downside one down, and then you get a negative reading. It's -1, right? And then your y is up, go up, right? In the up.
So there's the minus sign. The gravity is point to the ground.
Yes.
So the x-axis is point to the
sky. Point up, and then this is y-axis because you have see the second one is the maximum, right?
So that's the reason why this is -1, not the 1. So we can see if we turn the.
If you turn upside down, if you upside down, it will be +1.
Yeah, you can see this is upright, and so it's -1. If we turn it down, it's +1.
Yeah.
So that means this is if the y-axis is towards to the ground and the gravity is towards to the ground, so the sign is positive.
Yeah.
And similar thing to the x-axis and the z-axis.
Because for different iPhone, maybe the direction is slightly different. Maybe the same. I didn't try, but my one is similar with yours.
Have their own.
Yeah. You may. That's why we need how to identify the 3 exercise. Yeah.
So for the x-axis, it's similar. If we put the screen up, point to the sky, we can see the yellow line is. We can see this yellow line is -1, and if we put the screen to the point to the ground, we can see it's +1. That means the screen side is positive x-axis of let's see. Screen side is a positive side of z, and if we we put the right side to the sky, we can see the blue line here is -1, so it is to the left side, right left, right side of the phone is a positive axis of x-axis.
Yeah.
And so maybe I will briefly explain what this BCC is. So when we read the data from the phone, it will store to this workspace, and you can see this ACC variable is 1,000 times 3 vector. So if you double click it, you can see the data stored in this vector, and the rules here is the times. So each time you have three data is x, y, and z from the accelerometers, and if you don't move your phone quickly, so this three data is the projection of the gravity on each axis.
Yeah.
Okay.
Yeah, I think quite good. Like you give a good explanation of how to identify the exercise, because exercise is important. Especially when you detect your head movement, or you want to detect your when you do exercise. Sometimes, for example, we have a very big project with faculty. We basically want to identify this woman if pregnant. We how to identify before the deliver how much exercise she have done. So she has done. So we need to identify her. Sometimes it's lying down on the bed or is walking on the room in the room. So we need to use maybe one or two initial measurement unit. Actually, Li Wang is also working on that, right? So yeah, so we need to identify exercise direction first, and then we will develop the algorithm. So this is maybe mean too far for you, but I think identify the I share my screen. So identify the exercise is the first step. You use the IMU. So in this all the project I ask you to do is first you need to identify your X, Y, Z tracks. That means X, Y, Z accelerometer. First, you need to tell me what's the positive direction, the positive and the negative direction. They're opposite. That's the first requirement. In the I will go with you individually in each group, and maybe we stop our lecture quite soon, because I feel like each group explanation is not very sometimes it's not very specific. Maybe not is the quite the problem you really interested. So after I explain quickly, and then I will ask you to maybe first ask some questions you want to ask. So first I explain our procedure for all the project. So for no matter it's for fall detection or it's for the access monitoring. So the first step, you need to know how accelerometer works, because we are not use gyroscope or magnetometer at this stage. So for your project, so in that case, I suggest you to understand how accelerometer work. So maybe in your presentation, you can give a very brief introduction, and then you need to know how to identify the X, Y, Z accelerometer, the right direction, and they must satisfy the right hand rule. Why is that? I think this is not hard, and then this is the second requirement. The third requirement is like maybe we need to develop algorithm, because maybe next week maybe I how to get rid of some noise. So it's like, because last time I mentioned, like you cannot generate a movement is over 35 or even over 30 uh, hertz. So actually, even in that case, maybe 10 hertz, if you can try, even 10 hertz is difficult to generate. In that case, we design low pass filter. It's 10 hertz. But fortunately, for this one, we no need to design the filter to get rid of 10 hertz. You know why? So is any group understand why? Because our sampling frequency is only 20 hertz. Of course, you can increase the sampling frequency. You can increase the sampling frequency in the but the maximum sampling frequency is 100 hertz. That means you only can measure up to 50 hertz body movement. Uh, but if you set is 20 hertz, and then you only can measure up to 10 hertz your body movement. In that case, maybe we no need to design a filter. So we directly get rid of all the hertz noise already. So that is the good thing is but maybe I introduce how to design the filter, but you maybe not needed for your project. So, but the second stage is like filtering if necessary. And the third, for fall detection, uh, there's several ways, but you can use at least one way, just like to get the fall detection. So first is based on the analysis, so based on the theory behind. So you can see, for the if you have no other acceleration, just only have a gravity, and then if the three exercise square them together should be exactly as 1g, because no matter what direction you exercise, if the for each x square, y square, and z square, and then square root, this should be equal to 1g. So this is a very this normally is the case. That means no acceleration, zero acceleration. But sometimes you may be move slowly, and this is not moving. It's just like you're moving. So this is not fall. So for this case, for acceleration, x squared plus y squared, maybe I use another sharing to. So if so if I said this so this is upside down, and I need so for example, you have three accelerometer. One accelerometer side is x, so we use ax, and you have reading. So normally the reading is like this. So it's ax0. So this is the bias. That means even you don't have any input, they have some bias. But if you have the model, you can get rid of this one. And then you have a scalar factor. So they called kx and times the ax. So normally this is the input xs, and you also they have a model. If we can identify ax0 and kx, and then we can get ax the reading. So if we know the reading, and then we can have ay as well, and AZ as well. And then one of the method is you just calculate the square root of AX square plus AY square plus so AZ square. So this should be if no acceleration, so this one should be equal to 1g. So it's equal to local gravity. But sometimes if you're moving, and then this is maybe slightly greater or equal 1g. But if you have a falling down, and then this one will be much greater than 1g, maybe 2g, depends on how big the fall it is. So in that case, this is one kind of based on theoretical analysis. You can do lots of experiment. You can see for different fall, what's the threshold. So this is threshold. So this one maybe you use threshold as delta AF. So you need to identify the threshold. If you use 1G, it will be too sensitive. That means frequently have a false alarm. It's always tell you you have a fall, and it's very annoying. But if you put a too big threshold, for example, you put a 10G, then your system will not sensitive enough. That means always at no fault, unless you have very big fault, and then they tell you, oh, you have a fault. So this specificity is very good, but the sensitivity is very low. So in that case, it's also not good. So you need to find a very proper threshold. So for your fault detection. So in that case, I think like most important thing, first you need to test whether your system the model is right or not. That means how to test that. So you put because for the one I have seen Lee showed his mobile phone is already well calibrated. That means when you have no acceleration, you only have a gravity. So the total square root plus them together is nearly 1. That means the calibration very well. So this well calibrated. But sometimes if your accelerometer is not well calibrated, for example, you have drift, you have something, this one is not 0, or this one is not 1, and then you need to calibrate. So calibration, actually, normally I think all the accelerometer currently is well calibrated. I remember when I was 2 years ago, I read a paper, I think this all paper, so we presented an efficient auto calibration method. We do the tracks accelerometer calibration. So all methods no need to use any reference. So before the calibration, you need to have a rotation table. So that will be have a very accurate angle measurement. But always just directly use all the square root. All the square root should be equal to 1. We base on this principle, and then we develop the nonlinear modeling method. We can uh, calibrate the system. So we have several. This is our system to do the calibration. So after calibration, your measurement should around 1. That means if no acceleration, should around 1. I'm not sure. It's Lee. Hello, Lee. Hi, Wang Li.
Yes, yes.
Can you show your measurement? If you square root of all your x and y and z, is that the close to 1?
Okay.
Can you maybe you can show student? Uh, I stop sharing. You put one of them to see, but you need to not moving. When you not moving, you maybe select one of these to calculate.
This is data we just collect.
Yeah.
So I'll take this as an example.
Uh, you can see my understanding is nearly very close to 1. So this accelerometer is well calibrated, so no need recalibration. Square and plus, yeah, one. And square root. Yeah, you square root.
Point 0.98.
Yeah, but you make square root of this one.
The
你开根
gravity is
yeah
actually
开根号。
I know, I know. The gravity is actually near 0.98, not exactly
0.99. So it's very close, right? You can see it should be 1 because this is no 9.8 is the real value, but this is normalized. So normally you can see your reading is around 1. It's not around the 9.8. 9.8 is the real value. So your local gravity is around the 9.8. So this one is very close. You can see very close to 1. So in that case, this well calibrated.
Yes, I'll stop sharing.
Yeah, yeah. So this is I actually maybe find the maybe I have a different method, but one method is very simple method is we just uh, we just use this formula. Uh, you square of x, square of y, and square of z. You can do it online every time you have a reading, and then you just test. If this one, you can use a simple if then or if else sentence in the MATLAB, and you can make a threshold. Whether this greater than the threshold, and then you see, oh, this is a falling. So this is one method. This is a fall detection. So you need to because this one is I only give theory, but you need to implement in MATLAB, and also you need to lots of experiment to identify what's the proper threshold. So this is called one feature classification. So this is a, and then this is I mean is you theoretically you use a theoretical analysis, but you also have another method. You just like you don't know you no need to analyze the system, you no need to calibrate the accelerometer. You just do 10 times. For example, you do 10 times or or 20 times falling for different falling. You do lots of falling this way or that way and different location and things. You do lots of falling. Of course, you cannot do yourself. You just put on the table and push it down to do some different falling. And then you do something is no falling. You just move. You just hold this your smartphone just slowly moving, and then this called non falling. And then you use a classification method. This classification method I will teach you maybe week after next week. Next week I will teach you filtering a little bit, and then week after next week I will teach about how to do the classification. That means you have this data. You have lots of data. It's falling data and unfalling data. So in the real situation, in the society, they doing like this way. So this way is you no need to analyze the theory behind. You just do lots of big data. You do now you can everyone have a mobile phone, but the real falling down is very difficult to identify because unless you do it in purpose, but someone said this is not real. So but for you, it doesn't matter. You don't need to think about is it real fall or not. Just like you do some 100 times, or you have lots of data, and then you can use MATLAB, have a classification learner. I will show you very simple. And then you just put data there, and then you, for example, you identify one or two features. One of the feature is the square. You square all of them, square and square root. This one feature, and then you can do the use one feature to do classification. Or you can use another feature. For example, you calculate only y-axis. You maybe use x, y, and z square as a feature. In that case, you have three feature and plus square root and four feature. And then you do another classification. So this classification, if you never learn, I will show you what classification. For example, classification. For example, we have a male and female student. So how to classify this male or female? And then you measure two things. For example, you measure the length of the hair, and maybe that's only one uh, feature. That means normally female students have long hair, and male students have short hair. So in that case, you have a threshold, and then over that you said is female, and less than that is male. But this is maybe not accurate. And then you can find another measurement. For example, you measure the height, how taller you are. Normally, female is less taller than male. So in that case, as a second feature. And then you can use third feature, maybe the your weight. For example, normally the man have a very high weight, and the female have a low weight. And also you can measure some other uh, things like to do that different feature. So you can use 100 or even more features to identify male and female. Or you face recognition, you training put a lot of photo. So this is a female, this is male, and then the machine learning can tell you, can give you a automatic classification. So this, you no need to know inside. You just like know, give enough example. So that's why in the next 2 weeks you need to collect the data. You need to you either use theoretical analysis, just only use one feature I teach you. You just use the threshold, one threshold, or you can use different classification method. So this is for the fall detection. So I think group 1 and group 3, you are select the fall detection. So I think I will go with you individually after the lecture and discuss how to implement that. And another group, they are doing, you are doing motion, access monitoring. So access monitoring have two tasks you can finish, or you can select any of them, or you finish two of them. So one of them is it's like your rate estimation. So when you're working, can you tell how fast it is? So this one is they have two methods. One is the one I already show you. Use FFT. You can find the highest or the highest amplitude corresponding to the frequency. Because when you moving or working or running consistently, and then you will have a big magnitude is corresponding to the frequency of your working and running. So in that case, you put that one as the rate estimation. So this one is nearly there, but you need to do lots of experiment to see your working, normal working. You cannot change it to make small, slow, or you just normal working. Can you detect your rate, your working rate? Another method is you use you just like you detect is walking or running or sitting down or rest. You need to classify this because this is very important for motion tracking. So you maybe you only detect two, for example, walking and running. Can you tell the difference? One method is just use threshold. You after you measure the rate of your exercise, you can tell, oh, normally walking should be faster than sorry, running is faster than walking, and then you find the threshold. For example, it's 7 kilometers per hour, or 50 hertz. No, you cannot go 50 hertz. Maybe 3 hertz is for walking, over 3 hertz is running. So you need to find the threshold and to get it. This one method is just directly measure. Another is you do lots of experiment. You walking slowly and then you running fast, walking slowly, running fast. You have hundreds of data, and then you use classification method. Use classification learner. Use MATLAB. They can directly tell you are walking or running because you already trained them several times, and then you another times if you walking, and then they based on the based on the rate, they can tell you are walking or you are running. So that's for exercise classification. But also you can classify, for example, you're sitting down or you are resting, and with your running or your walking. So you have three class. You can do multi-class classification as well, but that will lead to a complex. I will discuss with you individually for each group what you want to do, and we will help you to finish the design. I hope you have after today you will have confidence to finish your project. Uh, so now we will go to we leave 1 hour to you, and I will individually discuss with you how to implement the project. Because you don't forget, you write your logbook, your journal, at least every week, maybe 1 or 2 times, and this will be 30% of your mark. Another 70% is from the final presentation. The final presentation is mainly present your result, your fault detection and access monitoring, access classification. Now, do you have any problem, any questions? Maybe I ask each group leader. So Amelia. Hi, Amelia.
So far, I don't have any questions, but
Okay.
if anyone in my group has any questions.
Is Amy or Jasmine?
I don't have any questions.
Okay, I will go to individually discuss with you about your project for detection. How about your group for the access monitoring? Hi,
Is that me?
Jason. Is that Jason?
Yeah. No, we good as well.
Okay, that's great. So how about Pranisa?
Yeah, all good.
Oh, good. Okay. So in that case, we start to go individually to do the project. So maybe Lee, we write for 5 minutes, and we break out the room, and then we start maybe at 15 past 11, a quarter past 11. We restart to discuss. So we first break out our room. Okay. So see you very soon, guys. Don't left, and I will discuss with you individually. Hi, Lee.